Hi, this is Steve with OS Nexus, and in this video we're going to go over how to use the QuantaStor command line utility, the QS CLI. The command line utility lets you do all the different operations that are available through the QuantaStor web interface at a command line that's really easy to automate. It's also got some nice output modes with JSON and comma separated value and XML, so it's easy to parse with your scripts. And so we're going to just jump in with a little bit of an overview of the CLI. We're going to go into how to authenticate using the CLI because you can use it to contact and configure remote QuantaStor systems and grids. And then we're going to go through some commands to actually provision some pools, some shares, and some volumes using the command line utility. And then we're going to go look at the documentation to wrap things up. So to kind of get started, what I've got here is two QuantaStor boxes in a grid of two appliances. This is ending in 23 and 24 here. And then I've logged into the first box. The command line utility is installed with every QuantaStor system. And so you can SSH in to the box in order to get access to the command line utility. But you can also download the command line utility from the website. And if you go to downloads, osnexus.com/downloads, if you scroll down, you'll see that there's a package available for Ubuntu Debian, for Windows, and Red Hat and CentOS. So there's an RPM, a Deb, and a Windows installer package. The command line utility works the same on all the different platforms. So all the different operations that we're going to go over today, you can use on any of the platforms. So let's see. Let's start off by going over a little bit of the command line syntax. So I'm logged in here via SSH to a QuantaStor appliance. I've logged in as QAdmin, and then I've did a sudo-i to elevate my permissions to root. I actually don't need root permissions to log in as to run these commands. You could log in as QAdmin and run the commands because the QuantaStor CLI requires you to authenticate as a client, no different than when you log in via the web UI. And so let's dive into that a little here. So here's if you just type the command line with no arguments, it gives you the usage page. And this is a great place to start. The QuantaStor command line utility expects that the first argument of any command that you run is the name of the command. So if we're going to go do a pool creation, that would be QS space pool-create. And that command is the first thing that you input on the command line. After that comes all of the various arguments for the command. Some arguments are mandatory, some arguments are optional. We put optional arguments inside of square brackets, and we put mandatory arguments without the square brackets. You can see that all of the arguments start with a double hyphen and then an equal sign. That's actually flexible. You can use a single hyphen, or you can use no hyphens. You can use the equal sign or no equal sign. It's pretty flexible so that you can use these arguments in different styles. So it supports all the various naming conventions. You'll notice also that all of the commands support --XML and --JSON. They also support a --CSV for comma separated value. So you can use those extra arguments to get it in an output that's easy to script and parse. This here indicates which QuantaStor server you're going to send the command to. And you can see here you can put the IP address, comma username, comma password, and that's how you authenticate with the remote box. We'll go into some other techniques so that you don't have to have the password on the command line here next, but that's how that works there. --min means show sort of minimal output. Some of the different list commands that's helpful with. No header means that when you do a list to leave the header out. But that's kind of it. Most of the operations also, if they support a force flag, you can do --flags force. Some of the commands require a force flag. If it's going to be like deleting a share or a volume or a pool, you have to apply the force flag. It'll give you an error saying that, hey, you need to apply the force flag if you run it without that. One other thing of note is this async flag. All of the various tasks, all the different operations that you can do, like creating a volume or a share, If you want the command line to come back immediately and not wait for that task to complete, just add -- flags async, or for shorthand, you can just add -- async, and it will run the command on the, it'll send the command to the QuantaStor system, start the task, and immediately return back. It'll give you the task ID so that you can then monitor the progress of that operation via the task ID. So that's a handy way if you want to run a bunch of commands and just have them asynchronously run and not have to wait for them to finish. You can run as many commands asynchronously as you want. QuantaStor will automatically queue the ones that need to be done in sequence. So if there's particular resources that multiple commands depend on, it'll just automatically queue those up in the order that you've sent them. All right, so we went over the output modes. These work with all the different commands. We went a little bit into the syntax. The command, remember, the command has to come first and then all the arguments. And this C also section is just other command line utilities that are installed on the QuantaStor system. So this really only applies when you're logged into a QuantaStor system. There's some extra little helper utilities that are there that are kind of not these aren't commands that are part of the QS command line, but other command line utilities. All of the help is available via QS help, but there's a lot of help output. So sometimes the -- min flag is helpful. If you do that, you can get just a list of the various commands in sort of a shortened output. If you want to get help on a specific area, you could just say help equals share, and that's just going to give you commands that have the word share in their name or in the documentation for it. So if we wanted to, like, say, find out more about share create, we could just say share create, and it's going to give us the two commands that match that term. If I leave the min flag off, it's going to give me the full detail of all the arguments and the description of these arguments for those commands. As we were mentioning earlier, the share, when you run the commands to, like in this case, do a share create, these two arguments are mandatory. And the special thing about a mandatory argument is that they allow you to give positional order. And what I mean by that is I could say share create and then give it the name of the share, say share 1, and the name of the pool, pool 1, without putting in -- name and -- pool. It knows positionally that the name should come first and the pool should come second. So we'll be using that in a little bit here next as I dive into starting to run some of the commands to show you how those work. So without further ado, let's start running some of these QuantaStor commands. So we're logged into this box here, QuantaStor 4223, and this is part of a grid of 2 appliances. When I run the command line, I can do anything that I want that's on any of the systems that are within the grid. So if I wanted to provision a pool on this box 24, I just need to be logged into either box 23 or 24. Any box in the grid can manage anything and everything that's within the grid. So let's start off by introducing you to the command to get the list of systems. So here we have 2 systems. I'm going to go and write QS sys-list. So every single object type that's in the entire system has a command to do a -list to get the list of those. So if I wanted to get a list of all the disks, and this is going to give me all of the disks on all of the systems, I can say disk list, and it's going to give me that output. One of the things that's really helpful with the disk list is it's got this really nice filter feature. So I can just say, hey, let me filter on just the local disks that are local to the system I'm logged into. So I'm on 4223, so it's going to just filter it to that. But let's say I want to filter it even further. I want to just see disks that are greater than 300 gigabytes in size, or let's, yeah, 400 gigabytes in size, let's say. And now you can see I've just got just a small handful of disks that come back. Some of these devices are, QuantaStor automatically sets up multipathing, and some of these, what you're seeing is actually paths. This here is a multipath device that has, you can see its identifier, and this is the underlying device for it. And so there's an argument also to just sort of like hide the paths. We can say the underlying multi-path paths. We can specify that, and now we just get usable devices that we can use to go create pools. Other things that we can do there is we can say we can do less than 400 gigabytes, and we can also say, hey, let's get a list of disks that are not used by pools, because we're going to go create a pool next, and there's nothing less than 200 gigabytes. Let's see if there's something less than, there's a whole bunch of disks less than 400 gigabytes that are unused. So now we can use that style of query to actually create a pool. So we're going to do that next. We're going to say pool create, and we're going to call it pool1, and the disk list we're going to give this is going to be dynamically created for us. Let's say we want 2 disks, and we're going to use a RAID type of RAID 1. This is going to go select 2 disks that are unused on the system 4223, which is the local thing box that we're connected to, that are less than 400 gigabytes in size, and it's going to go create a pool for us called pool1. And we can go over to the GUI here, and you can see in real time that's running. Here it's creating the pool for us. When this is done, it'll say completed, and you can see the output that we got is all the detail of the pool properties and all of its devices. When you're writing scripts, it's helpful to have this output in like an XML or a JSON format. So we're going to go create a volume in that pool next. Let's do a volume create. Volumes are the block devices. These are what you can access via Fiber Channel and iSCSI. And you can say we're going to create one called vol1. We're going to put that in our new pool, which we call pool1. Here, we'll go look at the pool list. Here's our pool1. In fact, here, QS pool dash list. You can see there's our pool. You can say QS volume dash list. And you can see we don't have any volumes yet, but we're going to go create one. So volume create vol1 on pool1. We want that to be, say, 10 gigabytes in size. What did I do wrong here? It says pool1 is not a number. It's looking for the name, the size, and then the pool. And that's where this is argument order dependent, right? We have to put the name of the volume first, then the size of the volume, then the pool to go create it on. So I had that in the wrong order. Name, size, 10 gigabytes, pool1. There we go. And I could have specified that using like this, name, size, pool. And here we'll go create this as volume 2. And again, you can see this happening real time in the UI. There's the volume 2 that we created. And if we go to the storage volumes, here you can see the 2 volumes that we've created. Now we can go in and delete the volumes, volume delete. We'll delete volume 2, the second one that we created. That's all there is to it. So if the volume was in use, it would have given us an error. It said, hey, this volume is in use. Are you sure you want to delete this? Use the force flag. So there's a bunch of protections to help prevent like accidental deletion of data. And then let's also go over creating a volume with JSON output. You just add --JSON, and we're going to get this volume created, and then this is all the JSON that describes the volume. So that's the unique identifier. And a little point on these GUIDs, these unique identifiers. Every single thing within QuantaStor is uniquely identified with a GUID. And so when we go and create something like this volume 3, we can refer to it by its name, or we can refer to it by its GUID. In some cases, you can have multiple objects of a particular type with the same name, and in that case, you'll get an error back saying, oh, I don't know which volume 3 you're referring to. Are you referring to the one that's on that system or that system? And so in those cases, you can get rid of the ambiguity by just specifying it by GUID. So here, we'll go and use that GUID, and we'll do a QS volume dash get on that particular GUID. You don't have to put it in quotes. You can just be like this. And we can also, like I was mentioning, we can refer to it by name, vol3, and there you have it. And you can do the CSV format as well. And here's the XML. So you can do it in any of these major formats. Snapshots. Let's dive in. Now that we have this volume 3 snapshot, let's go and create a snapshot of it. If you want to give it a name, you can just follow that with like vol3 snap, and it'll go create that snapshot for us. But you don't need to give it a name. It'll automatically generate one for you if you just go and run it without an argument. So let's see here. It created vol3 snap. Let's see here. QS help equals volume snapshot. And you can see, I need to specify --name because it's an optional argument. So it didn't know what that second argument was. Good argument for using the arguments in your scripts. So there, the volume that we're going to snapshot, and then the name of the new volume to be created. There we go. And now we're going to get that one with the name we intended. So there we go. There's the two snapshots, and you can delete them just as easily. So QS volume dash delete. We're going to delete that vol3 snap that we just created, and that's it. We deleted it. Some of these you'll see that it has sort of a list output. I apologize for the video. I've got my monitor resolution shrunk down a bit, so you see kind of the stuff scroll off. But generally, you just want to make the console window wider or opt for the JSON output. So here we can now do like a QS volume list, and we can see our volumes. With standard ZFS-based storage pools, which is the pool 1 that we created there, you can provision both block storage and file storage. So let's go through creating a network share. Those network shares are going to appear in this network shares tab. As you can see, we don't have any shares created yet. So we do a QS share -list. There's none in there yet. But now we'll do a QS share create, and we're just going to hit enter. It's going to say, hey, you didn't provide us with all the arguments, but here's the details on that command. So it's expecting a name of a share and the pool to create it in. Everything else is just going to get defaulted for us, but there's a bunch of things that we can override. We can enable CIFS and enable or disable it. We can set permissions. We can set the record size of the volume. All of these are various optional arguments, and you can see the detailed description on the right to go and change those from the defaults. Here, for just the demo today, we're just going to go and create a share called share1, and we're going to put it in pool 1. And that's all there is to creating shares. And again, if we want to see it in some other output format on what we created, we can just do --, again, like JSON. We're speaking a little bit earlier about creating shares where we didn't want to wait for the server to complete the command. Maybe we're going to go create a whole bunch of shares, and we want to move on with our script and not really wait for all that work to finish. You can just add --async onto the end, and you can see it came back immediately. It tells us it gave us a task object back saying I'm creating this network share, and that's this object right here. And then we can go and monitor the progress of that task. So we can say QS get task, task get, and we can see the progress of that. And you can see that task is already completed, and this custom ID field here contains our share that we created. So we can say QS share get, and that's the share that was created. This is showing us all of the various properties of the share. We can maybe do a CSV format, might be a little bit more compact for us, but that's all the properties of the share. The CSV format has this header section in case you're going to import it into like a spreadsheet or something, and then here's all the properties. Anyhow, that goes over how to use the command line commands. Again, if you forget, just type the command by itself, QS, and again, the help is a search feature, so you can say help equals, and then put in the word share, and it will show you all the commands that relate to creating shares, or just have the word share in it. Again, share create, you can do that, and it's going to give us the commands that have that in it. Let's talk about authentication, because here you might have noticed that we didn't have to put any passwords in, but in the field when you're writing scripts and automating things, you're going to need to authenticate against your systems because you're not going to have the default password in here. So when we're doing like a share list and we get this list of shares back, we are effectively providing a default argument here, which is server equals localhost admin password. So it's putting in the default admin password. If I was to put the wrong password in, it's going to give me an authentication error. Your password should be the first thing that you change on any given system, but for purposes of this demo, I've just left it at the default. Now, you oftentimes don't want to have to be typing in the admin password or any user's password on the command line. So one of the first things to do is to go and put these credentials into a credentials file. And you can just make one of these really easily. I'm logged in as root. I can put a credentials file on the root account for the server by echoing the password, the arguments of the server authentication argument to a file. And this is a special file name .qs.cnf for the QuantaStor CLI config file. And that's now going to use that as the argument. So if I say QS syslist, you can see I get my system list back. It's using that as the argument. So if I put in the wrong password into the config file and I run it again, you'll see authentication failed. Now, even though we have separated out the password to a separate file, it's often not a good idea to have plain text passwords. So there's a special argument. You can do QS CLI TKN in square brackets and put that in. What that means is that if you are logged in as root, and we are logged in as root, and I want to run a script as root, I can elevate my permissions to the admin account if I do a custom thing with the admin user account. And so here we're going to first try it, and we'll get an error back saying, "Hey, you're not authenticated. You can't use this as the password." But we're going to change that. We're going to say, "Hey, let's go to the user for the admin, and we're going to modify it so that we're allowed to elevate our permissions when we're logged in as root." So here you can see, if you'll read, you can see the tooltip that has more detail on this. If you forget, just go to the advanced settings. You can hover on it. It'll have more information about how to use this method. But now I'm going to modify this default admin account so that it allows me to run the command line as admin without having to authenticate, as long as I'm already authenticated and logged in as root. So here, this is going to work because I checked the box saying root is allowed. So now I don't have any passwords on the command line. I don't have any passwords in my QS config file, and I'm able to go and write all kinds of scripts that run on the local QuantaStor box. That technique is specific to scripts that can run within a QuantaStor appliance itself. So we've gone over how to authenticate using the QS command line using the QS comp file. We went over the QS CLI token technique. One other technique you can use is that you can set an environment variable with those arguments, and which is QS server, and that's another way that you can have your script export the credentials at the beginning and then go run a bunch of commands and not have to keep it in a config file. And then the last bit I wanted to show you is online. If you're looking for the documentation because you're trying to plan out how to script it, you can get all the documentation from the command line itself just with QS help, but all of this output that you see here is also available on our wiki page. So you can go here and find every single command. There's over 600 commands. Again, everything that you can do through the UI, you can script through the CLI. It goes through the same service interface that the user interface, the web user interface does. And that means, can you create entire Ceph clusters via the command line utility? You sure can. Can you create new grids from the command line? You sure can. So you can do literally every single command that's in the web UI. You can completely automate the provisioning of entire grids and clusters and shares and volumes purely through the command line. The other bit to note is, although we're kind of concentrating on the CLI here, every single command that is available through the CLI is also available through our REST API, and it's also available through our Python library. If you just type in QuantaStor Python library into Google, it'll take you to the Python website that has our library there. Well, I hope you enjoyed the video. That covers everything I wanted to cover today. If you have any questions, feel free to write us at info@osnexus.com, and thanks for watching.